All right, so we're going to end off Thursday of, or first, sorry, Tuesday of week 10, talking about energy expenditure, which is what we've already done. So here are our four objectives. So a lot of this is going to revolve around BMR, and then we're also going to talk about steady state. So as we've talked about on the last lecture, we can calculate how much energy someone is using for a given activity using a metabolic cart and RER. Now, there's this concept called basal metabolic rate, which is basically the bare minimum amount of energy that a person needs to survive. Okay, it's specifically defined as the rate of energy used at rest in the supine position after 8 hours of sleep. So the question I have to you is, how often are any of us meeting this condition? The answer is not very often. Okay, now it's the bare minimum, right? But there are things that can affect it. So the more muscle you have, the higher number of calories you'll use, so you'll have a higher BMR. If you have a bigger surface area, you're going to give off more heat. If you give off more heat, you're going to burn more calories to stay warm. If you're older, though, you're not going to use as many calories. Just by nature of being older, metabolism goes down, so your basal metabolic rate goes down. So it's one of the things that I'm dealing with as I get into my mid 40s. If you have a higher core temperature, that's going to cause you to use more calories. Remember, higher temperature speeds up reactions. If I speed up reactions, I'm going to use more energy. Okay, and then stress. Stress causes a fight or flight response that's going to cause you to use more energy, mobilize more glucose and glycogen. So you're going to use more calories. So there is a benefit to being stressed out during finals. Now, instead of using basal metabolic rate, we usually use resting metabolic rate. It's always greater than basal metabolic rate, but it's usually within 5 to 10%. Okay, so a typical resting metabolic rate is anywhere between 1,200 to 2,400 calories, and so this is just kind of the bare minimum, but more of a true resting as opposed to, hey, you've slept for 8 hours and you're lying on your back. All right, now average metabolic rate, so this takes into account everything you're using throughout the day. This is somewhere between 1,800 and 3,000 calories. However, some athletes, think football, offensive linemen, will exceed 10,000 calories. At one point, I know right after I turned 18, I was a freshman in college. I took a nutrition class in the summer. We had to track our um, food intake for 3 days and our weight. And in those 3 days, I lost a couple of pounds and I was eating 4,500 calories a day. Those were great times. All I was doing was eating, going to school, riding my bike or running. And since I lived in Utah, I was riding my bike up the canyon. So it wasn't like it was just this nice leisurely thing. And the competitive nature in me was every time I rode up the canyon, it's 13-mile round trip. How fast could I get up the canyon? There were a bunch of us that had this record, and every time I went out, I tried to break the record, which is not a good way to break a record. Anyway, when it comes to metabolic rate and exercise, this shouldn't come as a surprise. It might, but the harder the exercise intensity or the greater the intensity, the greater the metabolic requirement. Okay. Now, we can ultimately figure out how much it costs to do a specific exercise at a specific intensity if we reach steady state. And what we mean by steady state is that we've reached a point where oxygen consumption is consistent. Okay, so I believe 2 weeks ago, 3 weeks ago, you guys were doing submaximal exercise testing in lab. Now, if you're using a metabolic cart, you can actually measure the amount of oxygen that's being used. And if you did that and had somebody on the treadmill walking at 3 miles an hour at a 10% grade, after a couple of minutes, anywhere from 1 to 5 generally, they're going to reach steady. They're going to reach steady state, and you'll see this in their oxygen consumption, their CO2 production, and their heart rate. Okay, it'll be flat. But in order to determine steady state and if how many calories you're using for a given activity, you need to stay away from these 5 conditions. Okay, first, if you've got metabolic acidosis, that causes you to breathe more, which will cause your VCO2 to be higher than normal, which will cause your RER to be higher than normal, and so you will overstate how much energy is actually being used. This happens during maximal exercise, right? You experience that exercise hyperventilation, likely in response to metabolic acidosis. If you're not at steady state, so for example, you're in the first minute or so of an intensity, it takes a little bit of time for you to get to that steady state. And so you'll actually probably be underestimating your oxygen consumption and your energy utilization. Hyperventilation, so this one really here kind of goes with 1 and 2. That also inflates VCO2, causes increase in RER. And then finally, if you're low in carbs and doing some intense exercise, what will happen is instead of relying on carbs because you don't have very many, you're going to rely on protein. And protein isn't accounted for in RER. All right. Now, as a result, if you meet any of these conditions, like it says here, you're not really going to get a good estimate. And especially with number two goes to this one here. So RER might exceed 1.0. Okay, and that's because you're breathing out so much CO2 it overestimates RER. So I want to talk briefly about VO2 max. I know this is nothing new, but I just want to kind of reiterate this. So we've got this figure over here, and it's got watts on the x-axis, and we've got oxygen uptake, and really it should just say oxygen, not maximal oxygen, but oxygen uptake. And we've got two different scales here. One is just absolute oxygen uptake, so just how much oxygen you're actually using. And then this other one on the right side, we've got relative. Okay, so relative and absolute. Okay, so relative, we standardize it for body weight. It makes it a good way to compare among people, which we'll get into on the next slide. Now, as you can see, as intensity increases, so does VO2. Okay, now eventually we'll get to a point where we reach this plateau. So we've got it here and here and here and here. Okay, now what can cause us to reach our VO2 max but allow us to continue increasing our exercise intensity? Okay, and the answer is during these last two dots on each of these conditions, we're actually relying on glycolytic or anaerobic pathways. Okay, we've taken up as much oxygen as we possibly can. This might be limited by our respiratory system to get oxygen into our body. It might be limited by our cardiovascular system's ability to deliver the oxygen to the muscles, or it might be limited by the muscles' ability to take oxygen in. There's a lot of different factors that will affect this. Okay, but even though we'll max out, we'll still be able to go for a little bit longer because we're relying on those anaerobic systems. And so again, just to reiterate, this one is absolute over here, and this one is relative over here. All right, and so absolute is just how much oxygen you're using. All right, and the bigger you are, the more oxygen you're going to use. I think that's pretty straightforward. So I'm likely one of the biggest people that's in this class. So I'm going to use more oxygen likely than just about anybody. Okay, but when you standardize this for body mass, I might not. I have a good feeling that somebody like Leroy can utilize a lot more oxygen than I can because he's a much better athlete than I am. Okay, and so this relative value is something that we can use to compare individuals that are of different sizes and weights. Okay, and so at the end of the day, when you do a VO2 max test, well, this is a cool number. This one over here, this is what we're going for, right? And so I did mine the other day and I was at 51. So I'm trying to get back up to 55, but I was at 51, which isn't too bad for an old guy. And so that is where we're going to end.